Number one, in a flat corner with 30-meter radius, a car barely negotiates a turn. If the coefficient of friction is 0.655, how fast is it going? So we said part of the tricky part was doing a good free body diagram. I found it worked better to do a front view. Because then I could say, okay, I have gravity down, normal force up, same size as gravity. There has to be a force pointing towards the center. What force is pointing towards the center? Remember, Fc does not show up on my free body diagram. Well, friction. And this gives me my equation. Friction is what's pushing me in a circle. Friction is what times what? Mu times the normal force. I don't know the normal force. I think it's going to be mu mg equals m. Which version of AC am I going to use here? Okay. Did I need to tell you the mass of the car? As far as I'm concerned, there are 4 variables there, mu, g, v, and r. I can give you any 3 and you can find the 4th. Okay. The only way I'd ask you to find g, I'd have to tell you we were on a different planet. So we built a racetrack on a planet Duick. I could tell you what would g be there, right? Anyways, they want the v by itself. How would I get the r by itself? If they had asked me for that, I would times by r divide by mu g. So I'm going to get, anyways, v equals the square root of mu ger. V is going to be the square root of 0.655 times 9.8 times 30. Did you get 13.9 meters per second? If you got that, I would give you 3 out of 3. Otherwise, 1, 2, 3, 4, 5. I would probably give you 1 mark if I saw that, 1 mark for that, and 1 mark for the number. Answer. Yeah, I think that's all I can ask there. Oh, I was going to say, the reason I said barely negotiates a turn, if you did this speed, you would feel like you were about to lose control. You would be able to feel through the steering wheel to your hands, the car, the tires, I can tell they're about to slide. So, of course, you would never actually go this speed because you would almost certainly be very, very dangerous. Number 2, first thing I did is I crossed out the 2.5 grams, and I said that's 0.0025 kilograms, 2 zeros and then a 2.5, and I crossed out the 19 centimeters and made it 0.19 meters. I may have asked you this the other day. This question used to say a spider sits on a record player. Do you all still know what a record player is? Oh, okay. I've changed it to rotating platform because I suddenly thought, I don't know if they know what one of those is anymore. Okay. Good day, good day. So, if I do a little picture, I think it's going to be the same picture as the car, but instead of a car, I'll have a little spider. What are the forces acting on it? Get the obvious one. I'm going to have gravity, normal force. There has to be a force pointing towards the center. And again, I think it's friction. So my equation is going to be, well, first of all, they just want me to find the speed of the spider. The speed, I might be able to go 2 pi r over the period. Can I? Yeah, I know r. I know the period. So I'm just going to do that. It's going to be 2 pi, what was r? 0.19. And then 0.618. 2 pi times 0.19 divided by 0.618. And I get 1.93, is that right? Meters per second. Then it wants me to find mu. So now I'm going to go to my free body diagram and I'm going to argue that friction is what's pushing me in a circle. Do you have this quiz? Okay. Friction is mu times the normal force. I don't know the normal force. Hey, there's no hill or anything else, so I can go with good old physics 11. Mu mg equals m4 pi squared r over t squared. Because you found v in part A, you could also have used v squared over r. The only issue there is you'd be using an answer to find an answer, and so I'm going to hedge my bets and use the other one. But regardless, you'll get full marks. Oh, by the way, in the previous one, I would probably go 1 mark for the equation, half mark for the numbers, half mark for the answer. Little m cancels, so they didn't need to give me the mass of the spider. We want to get the mu by itself. I guess I would just divide by g. And again here, as far as I'm concerned, there are 1, 2, 3, 4 variables. If I give you any 3, you can find the 4th. Mu is going to be 4 pi squared. What was r? 0.19 all over 9.8, 0.618. Don't forget the yes. 4 pi squared 0.19 divided by bracket 9.8 times 0.618. Don't forget the squared, Mr. Dewick. Oh, yeah. Almost exactly 2. Is it 2.00? And then I made a little note. The spider has sticky feet, so you are going to get a mu bigger than 1. What are the units for the coefficient of friction? R none. Okay. So, Braden, in answer to your question, car going around a corner or spider hanging onto a record player, same physics, totally fair game as a written question on your test. Okay. I'm not saying there is one, but when I was making my mental list of these are the questions I might ask for horizontal circles, car going around a corner, or gravitron. Sorry, I said that wrong. Braden, listen closely. Car going around a corner, or gravitron is going to be on your test. You may have picked up a hint there. I don't know. A person is riding the gravitron. If the coefficient of friction between the rider and the wall they are leaning against is 0.45 and it's rotating with a period of 3.2, what's the minimum safe radius? This is a job for a free body diagram. What are the forces acting on this rider? You know what? I'll assume the wall is right there and that we're spinning in this direction. So there. What are the forces acting on this rider? Get the obvious one. Which way? Straight down? Is the rider sliding down? Is the rider sliding up? So I know there's an arrow pointing up the same side. That one is friction. Now, they're also tracing out a circle, so there has to be a force pointing that way. That's the normal force. And the reason this question is tricky is we're actually going to have 2 sets of equations. One of my equations is going to be normal force is what's pushing me in a circle. My other equation is going to be mg equals friction. Let's look here. They gave me the period, so I'm going to go normal force equals m4 pi squared r over t squared. They want me to get the r by itself. I know the period, I know the mass, I don't know the normal force. Why can't I say, oh, but look, I know another force the same size as the normal force. There isn't one pointing outwards. What haven't I used yet? These 2 are equal. Friction is what times what? So mg is going to be mu times the normal force. I guess that means that the normal force is mg divided by mu in this specific situation. And now I can walk that over here. I'll get mg divided by mu equals m4 pi squared r over t squared. Can little kids and grown-ups go on this ride? As far as I'm concerned, for this one, there are 1, 2, 3, 4 variables. That should sound kind of familiar. If I give you 3, you can find the 4th. Or instead of giving you the period, I could have given you the speed, and you would have used the v squared over r1, which is less work. But again, in that one, you'll find there are 4 variables. If I give you any 3, you can find the 4th. What do they want me to find? R. I guess divide the 4 pi squared over and times the t squared over. Sounds good? R is going to be g t squared divided by mu 4 pi squared. It's going to be 9.8. What was the period? 3.2. Don't forget the squared. All over, what was mu? 0.45 times 4 times pi squared. No idea what the answer is here. 9.8 times 3.2 squared divided by bracket 0.45 times 4 times pi squared. What was that? Oh, I thought I didn't make a mistake yet. Did you get 5.65? Meters. If you got that, 7 out of 7. Otherwise, 1, 2, 3, 4, 5, 6. I would probably go something like this. 1 mark if I saw that. 1 mark if I saw that. 1 mark if you got the normal force by itself. 1 mark for that, that's 4. 1 mark for the numbers, that's 5. 1 mark for that, that's 6. I'd probably give you 1 mark if I saw, you know what, actually, probably 1 mark if I saw that line somewhere. But if you got the right answer and showed some work, 7 out of 7. Can you give yourself a score out of 15, please?